Video you just watched, I showed you how you can use a table format to find the maximum volume of an object. But now what we're going to do is we're going to do that same problem, and we're going to use the calculus portion to be able to do this. So we're going to write the volume as a function of x. That would be part B. So V is going to equal, remember, it would be length times width times height is the volume formula. So V is equal to, the length would be 24 minus 2x. The width is 24 minus 2x. And the height is x. So what I'm going to do is actually go ahead and write this as x times 24 minus 2x squared. And I will go ahead and take this derivative. So use the calculus to find the critical number. So that means find the derivative of this. The one thing that people like to do incorrect is to use chain rule on this, and this is not a chain rule right now. You can't just bring the two out front. We have to use product rule. So we have to do first times derivative of the second plus the second times derivative of the first, which would just be a 1. So what this ends up giving me is negative 4x. So I'm taking and rewriting this first term, times 24 minus x squared, or x squared, 24 minus 2x, plus 24 minus 2x squared. Now, there's no easy way to go about solving for this. So what I'm actually going to do is, actually it might be easiest to, now that I look at this a little bit more, pull out a 24 minus 2x. So I'm going to go ahead and do that. 24 minus 2x, pull that out. I'm left with negative 4x plus, I'd have a 24 minus 2x left on the inside. So I took out a 24 minus 2x out of each of my terms. Hopefully that allows me to be able to do this. I never thought about doing this before. This ends up giving me on the inside then 24 minus 6x. So now I can take and set each of those equal to 0. This one will give me x is 12. And this one, 24 minus 6x equals 0, will give me x is 4. So I have two critical numbers on this, and so I want to know which one is the maximum. So I will try the different intervals. And in all honesty, all I really need to try is maybe 8 in here. So if I put 8 in here, I get a positive number because that would be 16, or 24 minus 16, which would be positive. And if I put 8 in here, I have 24 minus 48, which would be a negative. So a positive times a negative is a negative value. That means it's positive over here and positive over there. Because it's a polynomial, I can just jump to those conclusions. So it's increasing, then decreasing, then increasing. So that means that this is my maximum. And that's exactly what I found out in this chart. So I found my maximum was 4. The last thing we want to do is answer this question. So it says use a graphing calculator to verify the maximum volume. So I haven't actually found the maximum value. I know the maximum value from before, but to find the maximum volume, I would plug in 4 into my volume equation right here. So I would have 4 times, let's plug in 4 here, it'd be 16 times 16. And we actually did that back here on the chart. It was 1,024. So my maximum volume is that. I will not be doing the graphing calculator part of that. If you guys want to check that on the graphing calculator, you need to plug this into your y equals equation. You want to find 4, and then you could actually change your window height so that you would see that the answer would be 1,024. I have one more example, but I will show that in one more.